Hi, hello there. Welcome to Basic Device Configuration. You know that switches and routers come with some built-in configuration. So why would you need to learn to further configure switches and routers? Imagine that you purchase a model train set. After you had set it up, you realized that the track was just a simple oval shape and that the train cars only ran clockwise. You might want the track to be figure 8 shape with an overpass. You might want to have two trains that operate independently at each other and are able to move in different directions. How could you make that happen? You would need to reconfigure the track and the controls. It is the same with network devices. As a network administrator, you need detailed control of the devices in your network. This means precisely configuring switches and routers so that your network does what you want it to do. Let's get started. So this video lecture focuses on basic device configuration. At the end of this video lecture, you should be able to configure devices using security best practices. So topic includes configure a switch with initial settings, configure switch ports, secure remote access, basic router configuration, and verify directly connected networks. Let's start with the first section, configuring a switch with initial settings. So before you can configure a switch, you need to turn it on and allow it to go through the 5-step boot sequence. So after a Cisco switch is powered on, it goes through the following 5-step boot sequence. First, your switch will perform POST or power on self-test. Okay? So the switch loads a power on self-test or POST program stored in a ROM. POST checks the CPU subsystems. It tests the CPU, DRAM, and portion of the flash device that makes up the flash file system. This is similar to the computer doing the POST, wherein the computer has initially checking the hardware connected to it. Step number 2, the switch loads the bootloader software. The bootloader is a small program stored in a ROM that is immediately after POST successfully completes. The bootloader performs a low-level CPU initialization. It initializes the CPU registers, which control where physical memory is mapped, the quantity of the memory, and its speed. The bootloader then initializes the file system on the system board. And finally, the bootloader locates and loads a default iOS operating system software into the memory and gives control of the switch over the iOS. Let's talk about the boot system command. The switch attempts to automatically boot by using information in the boot environment variable. If this variable is not set, the switch attempts to load and execute the first executable file it can find. So on a Catalyst 2960 series switches, the image file is normally contained in a directory that has the same name as the image file, excluding the .bin file extension. Okay, now as you can see here in the figure, you have boot system flash C2960 LAN base K9 MZ 150-2.se slash C2960 LAN base K9 MZ 150-2.se.bin. Okay, now the boot system there is the main command. The flash, okay, this is the storage devices or the storage device. Now C2960 LAN base K9 MZ 150-2SE is the path to the file system. And the last one, this C2960 LAN base K9-MZ.150-2.se.bin is the iOS file name. Switch LED indicators. So Cisco Catalyst switches have several status LED indicator lights. You can use the switch LEDs to quickly monitor switch activity and performance. Switches of different models and feature sets will have different LEDs, and their placement on the front panel of the switch may also vary. Now the figure here shows the switch LEDs and the mode button for Cisco Catalyst 2960. Okay, now we have here the mode button. This is used to toggle through port status, port duplex, port speed, and if supported, the power over Ethernet or PoE status on the port LEDs. So let's start with the system LED. The system LED shows whether the system is receiving power and is functioning properly. If the LED is off, it means that the system is not powered on. If the LED is green, the system is operating normally. If the LED is amber or orange, the system is receiving power but is not functioning properly. So the second indicator is the RPS LED, or the redundant power system LED. It shows the RPS status. If the LED is off, the RPS is off, or it is not properly connected. If the LED is green, the RPS is connected and ready to provide backup power. If the LED is blinking green, the RPS is connected but is unable because it is providing power to another device. Okay? If the LED is amber, the RPS is in standby mode or in a fault condition. If that LED is blinking amber, the internal power supply in the switch has failed and the RPS is providing power. So the next indicator is the port status. Okay, now in this case, it is labeled stat. Okay, so this is a port status LED. It indicates that the port status mode is selected when the LED is green. This is the default mode. When selected, the port LEDs will display colors with different meanings. If the LED is off, there is no link, or the port was administratively shut down. If the LED is green, a link is present. If the LED is blinking green, there is an activity and the port is sending or receiving data. If the LED is alternating green or amber, there is a link fault. If the LED is amber, the port is blocked to ensure that the loop does not exist in the forwarding domain and is not forwarding data. So typically, ports will remain this state for the first 30 seconds after being activated. If the LED is blinking amber, the port is blocked to prevent a possible loop in a forwarding domain. So the next indicator is a port duplex LED, or labeled as duplex. It indicates that the port duplex mode is selected when the LED is green. When selected, port LEDs that are off are in half duplex mode. If the port LED is green, the port is in full duplex mode. So the next one is a port speed LED. It indicates that the port speed mode is selected. When selected, the port LEDs will display colors with different meanings. If the LED is off, the port is operating at 10 Mbps. If the LED is green, the port is operating at 100 Mbps. If the LED is blinking green, the port is operating at 1000 Mbps. Alright? So the last one here is PoE, or Power over Ethernet mode LED. So if PoE is supported, a PoE mode LED will be present. If the LED is off, it indicates that the PoE mode is not selected and that none of the ports have been denied power or placed in a fault condition. If the LED is blinking amber, the PoE mode is not selected, but at least one of the ports has been denied power or has a PoE fault. If the LED is green, it indicates that the PoE mode is selected and the port LEDs will display colors with different meanings. If the port LED is off, the PoE is off. If the port LED is green, the PoE is on. Okay? If the port LED is alternating green-amber, the PoE is denied because providing power to the power device will exceed the switch power capacity. So if the LED is blinking amber, the PoE is off because of a fault or problem. If the LED is amber, the PoE for the port has been disabled. Okay? Now, this table presents different combinations of the colors that has been presented in the previous slide. Now, let's talk about recovering from a system crash. Okay? So, the bootloader provides access into the switch if the operating system cannot be used because of missing or damaged system files. So, the bootloader has a command line that provides access files stored in a flash memory. So the bootloader can be accessed through the console connection following these steps. Step number 1, connect a PC by console cable to the switch console port. Configure the terminal emulation software to connect to the switch. So this terminal emulation software includes PuTTY or HyperTerminal or TerraTerm. Okay? Next would be unplug the switch, power cord, reconnect the power cord to the switch, and within 15 seconds, you need to press and hold down the mode button presented earlier in the previous slide while the system LED is still flashing green. Now you have to continue pressing the mode button until the system LED turns briefly amber and solid green, then release the mode button. And then finally, the bootloader switch prompt appears in the terminal emulation software on the PC. So you could type in help or question mark at the bootloader prompt to view a list of available commands. By default, the switch attempts to automatically boot up by using information in the boot environment variable. So to view the path of the switch boot environment variable, type the set command. Okay, so like what you see here on the screen. Then initialize the flash file system using the flash init command. Okay, so to view the current files in the flash as shown in the output here. So after the flash has finished initializing, you can enter the dir flash. So that means directory. Okay. So dir flash command to view the directories and files in a flash. Okay. So next would be enter the boot equals flash command to change the boot environment variable path the switch uses to load the new iOS in a flash. So to verify the new boot environment variable path, you need to issue the set command again. Okay, so finally, to load the new iOS, type the boot command without any arguments. Now, the bootloader commands support initializing flash, formatting flash, installing a new iOS, changing the boot environment variable, and recovery of lost or forgotten passwords. So if you want to recover password, then this is the commands, or these are the commands that you need to do. For example, the dir command can be used to view a list of files within a specific or specified directory. Next, let's talk about the switch management access. Maybe you will be asking questions like, why do we need to assign an IP address to a switch? So the answer is, this is to remotely access the switch or simply for remote management. So to prepare a switch for remote management access, the switch must be configured with an IP address and a subnet mask. So for instance, okay, so we have here a PC connected to the switch via the console cable. Okay, so to manage the switch from a remote network, the switch must be configured with a default gateway. This is very similar to configuring the IP address information on host devices. So in the figure, the virtual switch interface or SVI on switch should be assigned an IP address. The SVI is a virtual interface, not a physical port on the switch. A console cable is used to connect to a PC so that the switch can be initially configured. So by default, the switch is configured to have its management controlled through VLAN 1. All ports are assigned to VLAN 1 by default. For security purposes, it is considered a best practice to use VLAN other than VLAN 1 for management VLAN, such as VLAN 99 in the example. Okay? Now, the steps to configure switch management access. So first, you need to configure the management interface. So from VLAN interface configuration mode, an IP address and subnet mask is applied to the management SVI of the switch. So take note that the SVI for VLAN 99 will appear as up until VLAN 99 is created and there is a device connected to a switch associated with VLAN 99. Also take note that the switch may need to be configured for IPv6. For example, you can configure an IPv6 addressing on a Cisco Catalyst 2960 running an iOS version 15.0. You will need to enter the global configuration command. Okay, so SDM prefer dual IPv4 and IPv6 default, and then reload the switch. So after typing this command, you need to type in reload. Okay, so what are the tasks on the SVI configuration? Okay, so we have here the sample iOS commands. Now you need to start with something like, okay, so you are on the switch. Okay, so configure terminal and then interface VLAN 99. So we are going to create a virtual interface and that is called VLAN 99. And then we are going to assign an IP address, in this example, IPv4 address on that interface. So IP address 172.17.99.11, and then you've got a subnet mask of 255.255.255.0. Now, if you are configuring the management interface IPv6 address, so you have to do it this way. IPv6 address, and then 2001 DB8 ACAD 99::1/64. So after you have defined the IP address and the subnet mask, so enable the management interface by typing no shutdown. Okay, and then save the configuration using the command copy run start or copy run and config space startup config. Next would be, we need to configure the default gateway. The switch should be configured with the default gateway if it will be managed remotely from networks that are not directly connected to it. So because it will receive its default gateway information from a router advertisement or RA message, the switch does not require an IPv6 default gateway. Okay? Now, this can be configured, something like, okay, configure terminal, IP default gateway 172.17.99.1, and then you save the configuration. Third step is we need to verify the configuration. So you can use the command show IP interface brief. Okay, so that is for IPv4, and in here we can see that the interface VLAN 99 was configured with IP address 172.17.99.11, and the status here is down and down here. All right. So also in IPv6, you could have something like show IPv6 interface brief, and then you can see VLAN 99 current status is down and down. So status is down, the protocol is down, but you can see there the IP address assigned. So take note that an IP address applied to the SVI is only for remote management access to the switch. This does not allow the switch to route layer 3 packets. On this section, we will be talking about configure a switch ports. So let's talk about the duplex communication. So the ports of a switch can be configured independently for different needs. This topic covers how to configure a switch or switch ports, how to verify your configuration, common errors, and how to troubleshoot switch configuration issues. Okay, so the full duplex communication increases bandwidth efficiency by allowing both ends of the connection to transmit and receive data simultaneously. This is also known as bidirectional communication, and it requires microsegmentation. So a microsegment LAN is created when a switch port has only one device connected and is operating in full duplex mode. There is no collision domain associated with a switch port operating in a full duplex mode. Unlike full duplex communication, half duplex communication is unidirectional. Half duplex communication creates performance issues because data can flow in only one direction at a time, often resulting in collisions. So half duplex communications or connections are typically seen in older hardware, such as hubs. Okay? Full duplex communication has replaced half duplex in most hardware. Now the figure here illustrates full duplex and half duplex communication. As mentioned earlier, when you say full duplex, two switches can communicate simultaneously. Okay, so one device would be sending and another device would be receiving, and vice versa. Unlike if you are using the half duplex, one device will be sending and then the other device should be receiving. You can only send or receive data one at a time. Now, the Gigabit Ethernet and 10 GB NIC requires full duplex connections to operate. In full duplex mode, the collision detection circuit on the NIC is disabled. Full duplex offers 100% efficiency in both directions, transmitting and receiving. So this results in a doubling of the potential use of the stated bandwidth. Now let's configure switch ports at the physical layer. Switch ports can be manually configured with specific duplex and speed settings. So we use the duplex interface configuration mode command to manually specify the duplex mode for a switch port. So switch ports can be manually configured using this command duplex and speed here. So the default settings for both duplex and speed for the switch on the Cisco Catalyst 2960 and 3560 switches is auto. So 2960 is a layer 2 switch and 3560 is a layer 3 switch. Okay, and both of these switches are set to auto. Okay, now the 10, 100, or 1000 ports operate in either half or full duplex mode when they are set to 10, 100, and operate only in full duplex mode when it is set to 1000 Mbps or 1 gigabit per second. So auto negotiation is useful when the speed and duplex settings of the device connecting to the port are unknown or may change. When connecting to known devices such as servers, dedicated workstations, or network devices, a best practice is to manually set the speed and duplex settings. Now, when troubleshooting switch port issues, it is important that duplex and speed settings are checked. Okay? Now, we use the speed interface configuration mode command to manually specify the speed. For example, both switches here in the topology should always operate in a full duplex at 100 Mbps. Now, the table here shows the commands for switch 1. Now, the same commands can be applied to switch 2. Okay? Take note that any mismatch settings for the duplex mode and speed of a switch ports can cause connectivity issue. So auto negotiation failure creates a mismatched settings. Okay? So something like if you're going to set switch 1, okay, For instance, interface FA01, duplex full, speed 100. So same configuration should be applied on FA01 of switch 2. Okay. Now all fiber optic ports such as 1000 base SX ports operate only at 1% speed and are always full duplex. Okay, so let's talk about the auto MDIX. Okay, so until recently, certain cable types, straight through or crossover, were required when connecting devices. Okay, switch to switch or switch to router connections require using different Ethernet cables. Using the automatic medium-dependent interface crossover or the auto MDIX feature on an interface eliminates this problem. So you don't have to worry about a specific type of cable to be used. Something like I have to know which cable is a straight through and which cable is a crossover. Now with auto MDIX functionality, when this auto MDIX is enabled, the switch interface automatically detects the required cable connection type, straight through or crossover, and configures the connection appropriately. So you have nothing to worry about the types of cable to be implemented or to be used. So when connecting to switches without the auto MDIX features, a straight through cable must be used. Okay, so that is to connect to devices such as servers, workstations, or routers. Now crossover cables must be used to connect to other switches or repeaters. Now with auto MDIX enabled, either type of cable can be used to connect to other devices, and the interface automatically adjusts to communicate successfully. How cool is that? Okay, so on a newer switches, the MDIX auto interface configuration mode command enables the feature. Now when using the auto MDIX on an interface, the interface speed and duplex must be set to auto so that the feature operates correctly. Okay, now the command here to enable the auto MDIX is issued in an interface configuration mode on the switch as shown. Okay, MDIX, and then you've got auto. Now the auto MDIX feature is enabled by default on Catalyst 2960 and Catalyst 3560 switches, but not available on the older Catalyst 2950 and Catalyst 3550 switches. So to examine the auto MDIX settings for the specific interface, we use the show controllers Ethernet controller, okay, command with the PHY or P keyword to limit the output to lines referencing auto MDIX. Then we use include auto MDIX filter on the output. So something like show controllers Ethernet controller FA01 P, okay, and then pipeline include MDIX. So that would show only the output filtering auto MDIX. Now this table summarizes some of the more useful switch verification commands. So you could have the show IP or show interfaces, show startup config or show startup, okay, show run or show running config, show flash, show version if you want to display the hardware and the software status, okay, show history, display IP information about the interface, so show IP interface, or if you're using an IPv6, show IPv6 interface, okay, or you could have show MAC address table, okay, to display the MAC address table. Verifying switch port configuration. So usually we use the command show run, okay. This can be used to verify that the switch has been correctly configured. So from the sample abbreviated output on switch 1 here, show running config, okay. So from this one or from this output, we could see that fast Ethernet 018, okay, interface configured with VLAN 99. Now VLAN 99 configured with an IPv4 address 172.17.99.11 with subnet mask 255.255.255.0 or /24. Now, the default gateway is set at 172.17.99.1. Okay, so if you want to see all the configurations set on the switch, you just have to type in show run. So next command would be show interfaces command. This is another commonly used command which displays the status and the statistics information on the network interfaces of the switch. Now, the show interfaces command is frequently used when configuring and monitoring network devices. So the first line of the output of the show interfaces fast Ethernet 018 here indicates that the fast Ethernet 018 is up and up. So fast Ethernet 018 is up, line protocol is up, meaning that is operational. So further down, the output shows that the duplex is full. Okay, duplex is full duplex, and the speed is at 100 Mbps. Now let's talk about the network access layer issues. So from the output of the show interfaces command, this is useful for detecting common media issues. So one of the most important parts of this output is the display of the line and data link layer protocol status. Okay, so the first parameter here, fast Ethernet 018 is up. Okay, so you'll have this, fast Ethernet 018 is up. This refers to the hardware layer and indicates whether the interface is receiving a carrier detect signal. So it has something to do with the hardware. Okay, now the line protocol is up here, has something to do with the software. So the second parameter, okay, which is the line protocol is up, refers to the data link layer and indicates whether the data link layer protocol keep alives are being received. So based on the output of the show interfaces command, possible problems can be fixed as follows. Okay, so if the interface is up and the line protocol is down, a problem exists. There could be an encapsulation type mismatch. The interface on the other end could be error disabled, or there could be a hardware problem. Okay, if the line protocol and the interface are both down, the cable is not attached, or some other interfaces problem exists. For example, in a back-to-back connection, the other end of the connection may be administratively down, or it was not issued with a no shutdown command. Okay, so if the interface is administratively down, we only have one solution to that. It has been manually disabled. Okay, the shutdown command has been issued in the active configuration. Okay, now to address this administratively down, we simply have to enable the interface with the no shutdown command. Okay, so how about the show interface command output displays counter and the statistics for fast Ethernet 018 interface here. Okay, so some media errors are not severe enough to cause the circuit to fail, but do cause network performance issues. Okay, so we have runs here, runs packets that are discarded because they are smaller than the minimum packet size for the medium. For instance, any Ethernet packet that is less than 64 bytes is considered a runt. Alright, you also have giants. Giant packets are discarded because they exceed the maximum packet size for the medium. So for example, any Ethernet packet that is greater than 1518 bytes is considered a giant. Okay. Next, you also have here the input errors. Okay, input errors, total number of errors. It includes runts, giants, no buffer, CRC or the cyclic redundancy check, frame overrun, and ignored counts. You also have the CRC errors that are generated when the calculated checksum is not the same as the checksum received. So output, okay, errors, sum of all the errors that prevented the final transmission of datagrams out of the interface that is being examined. You also have collision number of messages retransmitted because of an Ethernet collision. And late collision numbers here, a collision that occurs after 512 bits of the frame has been transmitted. Now, this table explains some of the common errors which can be detected using the show interface command presented in the previous slide. Let's talk about the interface input and output errors. Okay, so input errors is the sum of all the errors and datagrams that were received on the interface being examined. We briefly mentioned this in the previous slide. This includes rants, giants, CRC, no buffer, frame, overrun, and ignored counts. The reported input errors from the show interface command includes the following. So you've got the rant frames, giants, and CRC as explained earlier. Now, output errors is the sum of all the errors that prevented the final transmission of datagrams out the interface that is being examined. The reported output errors from the show interface command includes the following. You've got collisions, okay, and late collisions. So collisions in half duplex operations, these are normal. However, you should never see collision on an interface configured for full duplex communication. So you also have late collisions. A late collision refers to a collision that occurs after 512 bits of the frame have been transmitted. Excessive cable lengths are the most common cause of late collisions. So another common cause of late collision is the duplex misconfiguration. For example, you could have one end of the connection configured for full duplex and the other end for half duplex. So you would see late collisions on the interface that is configured for half duplex. In that case, you must configure the same duplex settings on both ends. Okay? So a properly designed and configured network should never have late collisions. Troubleshooting network access layer issues. So most issues that affect a switch network are encountered during the original implementation. So theoretically, after it is installed. So a network continues to operate without problems. However, cabling gets damaged, configurations changed, and new devices are connected to the switch that requires switch configuration changes. So ongoing maintenance and troubleshooting of the network infrastructure is required. Okay? Now, to troubleshoot scenarios involving no connection or bad connection between a switch and another device, be a router or a PC, we need to follow this general process shown in the figure here. So let's start with this area here. Okay, so we use the show interface command to check the interface status. If the interface is down, okay, is the interface up? No, so that means the interface is down. We need to check, okay, to make sure that the proper cables are being used. Additionally, check the cable and connectors for damage. So if a bad or incorrect cable is suspected, replace the cable. So if the interface is still down, the problem may be due to a mismatch in speed settings. Okay? The speed of an interface is typically auto-negotiated. Therefore, even if it is manually applied to one interface, the connecting interface should auto-negotiate accordingly. So if a speed mismatch does occur through misconfiguration or a hardware or software issue, then that may result in the interface going down. Manually set the same speed on both connection ends if the problem is suspected. So we are doing some troubleshooting here. Okay? Now, what if the interface is up, but issues with connectivity are still present. Okay, so using the show interface command, check for indicators of excessive noise. Indications may include an increase in the counters for runs, giants, and CRC errors. So if there is an excessive noise, first find and remove the source of the noise, if possible. Also, verify that the cable does not exceed the maximum cable length and check the type of cable that is being used. So if noise is not an issue, you check for excessive collisions. So if there are collisions or late collisions, verify the duplex settings on both ends of the connection. Much like the speed settings, the duplex settings is usually auto-negotiated. If there does not appear, or if there does appear to be a duplex mismatch, then manually set the duplex to full on both ends of the connection. Okay, now that would solve the problem. If not, you need to document the work done and escalate the issue, okay, on the organization. So on this section, we will be talking about secure remote access. So you might not always have direct access to your switch when you need to reconfigure or to configure it. You need to be able to access it remotely, and it is imperative that your access is secure. Okay, so this topic discusses how to configure a secure shell or SSH for remote access. So a packet tracer activity gives you the opportunity to try this yourself. Okay, now Telnet uses TCP port 23. It is an older protocol that uses unsecure plain text transmission of both the login authentication, username and password, and the data transmitted between communicating devices. So a threat actor or a hacker can monitor packets using Wireshark. For example, now in this figure, the threat actor captured the username admin and the password CCNA from the Telnet session. Okay, so your Wireshark application can read that packet, and it could display, or it will display, the username and the password here in plain text. Okay, so that is why we are using the SSH or the secure shell. Okay, so this is a secure protocol that uses TCP port 22. So it provides a secure encrypted management connection to remote device. So SSH should replace Telnet for management connections. SSH provides security for remote connections by providing strong encryption when a device is authenticated, username and password, and also for the transmitted data between the communication or communicating devices. So the figure here shows Wireshark capturing an SSH session. So the threat actor can track the session using the IP address of the administrator's device. However, unlike Telnet, SSH, okay, with SSH, username and password are now encrypted. So you cannot read it. All right. Next, so how do we verify that the switch supports SSH? So to enable SSH on the Catalyst 2960 switch, the switch must be using version of the iOS software including cryptographic or encrypted features and capabilities. We can use the show version command on the switch to see which iOS the switch is currently running. So an iOS file name that includes a combination K9 supports cryptographic or encrypted features and capabilities. As you can see here, you've got K9 there. Okay. So this example shows the output of the show version that supports SSH. So how do we configure SSH? So before configuring an SSH, the switch must be minimally configured with a unique hostname and the correct network connectivity settings. So step 1 is we need to verify SSH support. Okay, so use the show IP SSH command to verify that the switch supports SSH. So if the switch is running an iOS that supports the cryptographic features, then this command here, show IP SSH, is recognized. Okay. Step number 2 is configure the IP domain. So configure the IP domain name of the network using the IP domain name or domain name global configuration mode command. In this figure, the domain name value is cisco.com. Step number 3, generate RSA key pairs. Now, not all versions of the iOS default to SSH version 2, and SSH version 1 has unknown security flaws. So to configure SSH version 2, we issue the IP SSH version 2 command. Okay, that is on the global configuration mode. Now, generating an RSA key pair automatically enables SSH. We use the crypto key generate RSA global configuration mode command to enable the SSH server on the switch and generate an RSA key pair. Now, when generating an RSA keys, the administrator is prompted to enter the modulus length. Okay. Now, the sample configuration in the figure uses a modulus size of 1024. All right, or 1024 bits. A longer modulus length is more secure, but it takes longer to generate and to use. So take note that to delete the RSA key pair, we use the crypto key zeroize RSA global configuration command. After the RSA key pair is deleted, the SSH server is automatically disabled. Okay, so the command is crypto key zeroize. Okay, that's 0 IZE RSA global configuration mode command. So step number 4, configure the user authentication. So the SSH server can authenticate users locally or using authentication server. So to use the local authentication method, create a username and password pair using the username, secret, all right, something like username admin secret CCNA. Okay, so that is username, and then secret the password. Okay, on the global configuration mode. Now in this example, again, the user is set to admin and our password is CCNA. Step number 5, you need to verify, okay, or to configure the VTY lines. So enable the SSH protocol on the VTY lines using the transport input SSH. Okay. Now the Catalyst 2960 has VTY lines ranging from 0 to 15. This configuration prevents non-SSH such as telnet, okay, or telnet connections, and limits the switch to only accept SSH connections. Now use the line VTY global configuration mode command and then log in local configuration mode command to require local authentication for SSH connection from the local username database. All right, step number 6, enable SSH version 2. By default, SSH supports both version 1 and 2. When supporting both version, this is shown in the show IP SSH output as supporting version 2. So enable SSH version using the IP SSH version 2 global configuration command. Okay, so something like IP SSH version 2. So next would be, let us verify the SSH is operational or running on the switch. So on a PC, an SSH client such as PuTTY, TeraTerm, okay, or Hyperterminal can be used to connect to an SSH server. For example, assume the following is configured. Okay, the SSH is enabled on switch 1. Okay, the interface VLAN 99 or SVI with IP address or IP before address 172 1799.11 on switch 1. PC1 with IPv4 address 172.99.21. So if you are using PuTTY, okay, you could simply click on the host name there, okay, or you could type in the IP address. The port is, take note, port 22. You've got SSH there. Okay. Now, when connected, the user is prompted for a username and password as shown in the example. So using the configuration from the previous example, the username admin and the password CCNA are entered. So after entering the correct combination, the user is connected via SSH. Okay, that is to the command line interface or CLI on the Catalyst 2960 switch. Okay, so next would be, let us verify if SSH is operational. So to display the version and configuration data for SSH on the device that you configured as an SSH server, we use the command show IP SSH command. Okay, in the example, SSH version 2 is enabled. All right. On this section, let's talk about the basic router configuration. So up to now, this module has only covered switches. So if you want devices to be able to send and receive data outside your network, you will need to configure a router. So this topic teaches you basic router configuration. Cisco routers and Cisco switches have many similarities. They support a similar modal operating system, similar command structures, and many of the same commands. In addition, both devices have similar initial configuration steps. For example, the following configuration tasks shows or should always be performed. Okay, name the device to distinguish it from other routers and configure passwords as shown in this example. So usually, I ask the students whenever they use a router, whenever they face this PuTTY, okay, with a switch and a router, the very first requirement is to set the host name. Okay, so something like, okay, so configure terminal, host name, R1 in this example. Okay, and then line console 0, password is Cisco, login. Okay, line VTY 0 to 4, password is Cisco, login. Okay, and then you've got service password encryption. Now this will encrypt all the passwords set on this router. Configure a banner to provide legal notification of unauthorized access as shown in the example. So we are using banner MOTD. You've got a $sign and then the text or the message you want to display on your screen. So take note that the use of the banner is for legal notification of unauthorized access. This is not to welcome anyone on accessing your device. All right. So next would be save the changes on a router as shown in the example. So after you have set the host name, all the passwords, and including the banner, so it's time for us to save our configuration. So we do that via copy running config, startup config. So same with a switch. So for the basic router configuration, so we will be using this dual stack topology here. One distinguishing feature between switches and router is the type of interfaces supported by each. So for example, a layer 2 switch support LANs. Therefore, they have multiple fast Ethernet or Giga Ethernet ports. The dual stack topology in the figure is used to demonstrate the configuration of router IPv4 and IPv6 interfaces. So this topology here is used throughout the course of the discussion. Let's configure the router interface. Router supports LANs and WANs and can interconnect different types of networks. Therefore, they support many types of interfaces. For example, the G2 ISRs have one or two integrated gigabit Ethernet interfaces and high-speed WAN interface card or the HWIC slots to accommodate other types of network interfaces, including serial, DSL, and cable interfaces. To be available, an interface must be configured with at least one IP address. We use the command IP address, okay, IP address and then subnet mask, and IPv6 address, IPv6 address slash prefix interface configuration commands for IPv4 and IPv6 respectively. Next is it should be activated. So by default, LAN and WAN interfaces are not activated. So it is shut down. Now to enable these interfaces, it must be activated using the no shutdown command. So again, this is similar to powering on the device or on the interface. The interface must be connected to another device, a hub, a switch, or another router for the physical layer to be active. Okay? So description, this is optional. Optionally, the interface should be configured with short description of up to 240 characters. So it is a good practice to configure description for each of the interface. So this is equivalent to programmer's note or comment in a program. Okay? On production networks, the benefits of interface descriptions are quickly realized as they are helpful in troubleshooting and identifying a third-party connection and contact information. Okay, so we have here an example configuration. Okay, so referring to R1 here, okay, so take note that on R1, we have three directly connected networks here. A network where PC1 is in, a network where PC2 is in, and the network between this R1 and R2 here. Now, what we're going to do here is to configure Gigabit Ethernet 0/0/0 here, where S1 and PC1 is connected to. So to get into it, so interface Gigabit Ethernet 0/0/0, IP address, that is 192.168.10.1. That's last 24. So you've got 255.255.255.0. Okay. Now, if we are going to configure an IPv6 on that interface, so that is IPv6 address, that is 2001 DB8 ACAD 1::1, and that is /64 there. Okay. Now, you might want to give some description on that link. Interface Gigabit Ethernet 0/0/0 is a link to LAN 1. And then, of course, we have to activate it with a no shutdown command. All right. So same thing. We need to configure Gigabit Ethernet 0/0/1 with IP address 192.168.11.1. Okay, that's last 24. So that's 255.255.255.0. Now, if you are configuring it with IPv6, so IPv6 address 2001 DB8 ACAD 2::1/64. Okay, so likewise, you might want to give a description on this link, so something like link to LAN 2, and then activate it with no shutdown command. So same thing with serial 0/0/0 here. Okay, serial 0/0/0. Now on this example, it's serial 010 in here. So there must be some error on this topology here. Okay, so but then assuming that this is serial 0/0/0, IP address is at 209.165.200.225. All right. Okay, so and then that's last 30. That is 255.255.255.252. So if you're going to follow this topology, this should be serial 0/1/0. All right. And then IPv6 address, something like 2001 DB8 ACAD 3::225/64, and then activate it with no shutdown command. So that's how simple it is to assign an IP address on the interface of a router. So next would be the IPv4 loopback interfaces. So multiple loopback interfaces can be enabled on a router. Okay, so the IPv4 address for each loopback interface must be unique and unused by any other interface. Okay, so as shown in the example configuration of loopback interface 0 on R1 here. Okay, so something like interface loopback 0, you could assign an IP address to it. Okay, and that's it. All right, so the IPv4 loopback interface, another common configuration of Cisco iOS routers, is enabling this loopback interface. It makes sense on the forthcoming topics that we're going to discuss. Now, the loopback interface is a logical interface that is internal to the router. It is not assigned to a physical port and can never be connected to other or any other devices. It is considered a software interface that is automatically placed in an app state as long as the router is functioning. Okay? Now, the loopback interface is useful in testing and managing the Cisco iOS device because it ensures that at least one interface will always be available. For example, it can be used for testing purposes, such as testing internal routing processes by emulating networks behind the routers. So loopback interfaces are also commonly used in lab environments to create additional interfaces. For example, you can create multiple loopback interfaces on a router to simulate more networks for configuration practice and testing purposes, as shown earlier. Okay? The IPv4 address for each loopback interface must be unique and unused by any other interfaces. Okay? Now, in this curriculum, we often use loopback interface to simulate a link to the internet. Okay? Now, to configure a loopback, simply interface loopback number. Okay? And then give it an IP address and a subnet mask, as shown earlier. On this section, let's talk about verify directly connected networks. So there are several show commands that can be used to verify the operation and configuration of an interface. The topology in the figure is used to demonstrate the verification of a router interface settings. Okay? The topology presented earlier, which is a dual stack topology. Now, the following commands are specifically or especially used or useful to quickly identify the status of the interface. So I usually use the command show IP interface brief command for IPv4 or show IPv6 interface brief. This will display the summary of all the interfaces, including the IPv4 and IPv6 addresses and the interface status. All right, current operational status of the interface. So another command that you can use is show running config interface and then the interface number. This displays the commands applied to the specific interface. Okay, or you could go directly with the routing table, show IP route for IPv4 and show IPv6 route for IPv6. Now in here, what you can see are the directly connected networks denoted by C or L, okay, so denoting the IP address configured on the local interface. Now the output of the show IP interface brief, okay, and show IPv6 interface brief command here. So take note that it displays the interface, the IP address assigned, and the status, okay, and the protocol status also. That is good for IPv4 and IPv6. So this command here is very useful, especially when doing troubleshooting. Okay, so verify IPv6 link local and multicast addresses. Okay, now the output of the show IPv6 interface brief command displays two configured IPv6 per interface. Okay, so one address is the IPv6 global unicast address that was manually entered. Okay, and the other address begins with FEAT. Okay, FEAT, So which is the link local unicast address of the interface. The link local address is automatically added to the interface whenever a global unicast address is assigned. So an IPv6 network interface is required to have a link local address, but not necessarily a global unicast address. Okay? So you could also use the specific commands here, something like show IPv6 interface gigabit ethernet 0/0/0 here. Displays the interface status and all of the IPv6 addresses belonging to the interface. So along with the link local address and the global unicast address, the output includes the multicast addresses assigned to the interface, beginning with prefix FF02 as shown in the example. Verify interface configuration. So the output of the show running config interface gigabit ethernet 0/0/0 here, okay, this displays, okay, the specified interface as shown, and the following two commands are used to gather a more detailed interface information. Okay, so you could use the show interfaces, which displays the interface information and the packet flow count for all the interfaces on the device. Okay, so you also have the show IP interface or show IPv6 interface, displays both the IPv4 and IPv6 respectively related information for all the interface of a router. Or you could simply type in show run, okay, and then just look for the interface there. So the output of the show IP route and the show IPv6 route command reveals the three directly connected networks entries and the local host route interface entries as shown in the example here. So if you are going to evaluate this is on R1, and R1 has directly connected networks. Okay, so this network here, this one, and this one here. Okay, so these are the three C's there, and the three L's are of course the IP addresses configured on those interfaces. This is for IPv4 and this one is for IPv6. Okay, now the local host route has an administrative distance of 0. If you'll observe, you've got 0 there. Okay, so that's the administrative distance or the level of believability. So you're gonna learn more of it on the next video lecture. It also has a /32 mask for IPv4, okay, and a /128 mask, okay, for IPv6. The local host route is for routes on the router that owns the IP address. It is used to allow the router to process packets destined to that IP. Okay, so also you've got C there. So the C next to the route within the routing table indicates that this is a directly connected networks. When the router interface is configured with a global unicast address and it is in up state, okay, the IPv6 prefix and prefix length are added to the IPv6 routing table as a connected route. So the IPv6 global unicast address applied to the interface is also installed in the routing table as a local route. Okay, so the local route has 128 or /128 prefix, and the local routes are also used by routing table to efficiently process packets with the interface address of the router as the destination. You can also have the filter show output command, okay, something like you just have to run show run, all right, that is the commonly used command, show run. But if you want to filter the output with that show run command, you could include these 4 filtering parameters that can be configured after the pipeline. Okay, so show run, and then something like pipeline, section, include, exclude, and begin. Let's go through it and start with the section. Okay, now section shows the entire section that starts with filtering expression as shown in the example here. So show run or show running config pipeline section line VTY. Okay. So again, this will display the section that starts with line VTY. So you've got line VTY 0 to 4. That would display the entire section. Okay, beginning with line VTY. So the next one is include. So for instance, you've got show IP interface brief. This is your output here. But if I'm going to have the filter output, something like instead of typing in show IP interface brief, I would like to type in show IP interface brief pipeline include app. So this would display only, okay, the interfaces or the status with the app state there. So take note that in here, serial 011 is down, but you want only to see app, then only the app status will be displayed. That's with the include command. Okay, the include includes all the output lines that match the filtering expression. So the third one is exclude. Excludes all output lines that match the filtering expression as shown in the example. So again, something like we have show IP interface brief. So you might want to have show IP interface brief, exclude unassigned. Okay, so that would display only this. Okay, excluding unassigned. All right, and the last one is begin. It shows all the output lines from a certain point, starting with a line that matches the filtering expression as shown in the example. Okay, so something like show IP route, pipeline begin gateway. So that would display the section starting with gateway. Okay, the output filters can be used in combination with any show command. All right, so next would be the command history feature. So the command history feature is useful because it temporarily stores the list of executed commands to be recalled. So I usually use the arrow key or the up arrow to display the historic or the previous commands typed in. Okay. So an example of the terminal history size and show history commands, okay, is shown in the figure. Okay, so terminal history size is 200. Okay, show history. These are the commands that you have just recently used. All right. So by default, the command history is enabled and the system captures the last 10 command, okay, in the history buffer. So as shown earlier, we can use the show history privilege exec command to display the contents of that buffer. All right. So that's the end of this video lecture. See you on the next video. Have a great day.